Hello students and welcome to my channel Maths Hub. So today in this video, I'll focus upon matrices and we will talk about the quadratic forms. So to begin with, what is a quadratic form? So any homogeneous polynomial of second degree in any number of variables is called a quadratic form. So you might be wondering that what is a second degree polynomial? So let's see some examples. You can see the first example where we have taken the polynomial as ax squared plus 2bxy plus cy squared. So you can see that the entire polynomial has degree 2. All the terms, if you check, the first term has degree 2, the second term has degree 2, the third term also has degree 2. So this is a homogeneous polynomial. Homogeneous means the polynomial should have the same degree throughout. So this is a homogeneous polynomial of second degree. So you can see that the degree is 2. So we can extend the same polynomial with 3 variables, with 4 variables, with any number of variables, right? So let us see another example. So here you can see that this is a homogeneous polynomial of second degree. And how many variables are here? There are 3 variables, x, y, and z. So the polynomial becomes ax squared plus by squared plus cz squared plus 2hxy plus 2gyz plus 2hxz, right? Where a, b, c, h, g, and h, they are coefficients. Now, let us take another second degree polynomial in 4 variables. So here you can see that the polynomial is ax squared plus by squared plus cz squared plus dw squared plus 2hxy plus 2gyz plus 2hzw plus 2lxz plus 2myw plus 2nxw. Right? Now the question is that if any matrix is given to us, can we reduce it to a quadratic form, that is a second degree polynomial? And similarly, if a second degree polynomial is given to us, can we convert that into the form of a matrix? Let us see that. So how to convert any matrix or any quadratic form in the matrix expression? So any quadratic form can be written as summation I and j going from 1 to n, aij, xi, xj. How this is possible, we'll just see in the following presentation. See, when I multiply a row vector, that is x1, x2, xn, with the coefficient matrix A, which is having the elements a11, a12, a1n, the second row is a21, a22, a2n, and the nth row is an1, an2, ann. And again I multiplied with a column vector, that is x1, x2, xn. What will this give us? It will give us a polynomial expression in terms of a11 x1 square, a22 x2 square, ann xn square, and similarly I will get all sorts of mixed terms like a12 x1 x2, a21 x2 x1. Similarly, that means you will get a polynomial expression as aij, xi, xj, and I and j will always run with the suffixes 1 to n, right? So this is how you express any polynomial in matrix notation, and like vice versa, any quadratic form can be expressed in the form of a matrix, right? So now, similarly, if we have two variables, like if I have the polynomial ax squared plus 2hxy plus by squared, how will I write this in the form of a matrix? You can always write it as x transpose ax, where what are the values of x and a? X is the row matrix xy, that is x transpose. And if I take x, x is the column vector, that is xy. And what is happening in the coefficient matrix? You can see that the diagonal positions are all the pure terms, that is x square and y square. We are writing a and b. And this term 2hxy has been divided into two parts, and we are writing h and h over here. Right? Now, how we are getting this matrix of quadratic form, that we will see in the next slide. Likewise, if I check the three variable concept in matrix notation, and if I have a polynomial ax squared plus by squared plus cz squared plus 2hxy plus 2fyz plus 2gzx, how we are writing it? All the pure terms, that is x squared, y squared, and z squared, the coefficients are placed along the diagonals, And then you can see that these two positions, 2h has been divided into two parts, equal parts, HH. Then 2f is divided into f and f in these two positions, and 2g is divided into these two positions as half of 2g, that is g and g. Now the question is how we are getting this matrix. Let us talk about this. Now what is the method? What will you do? For example, you have this quadratic form. What will you do? You will make a matrix over here, and above the matrix write the variables x, y and z. You will not write it, you will just assume it mentally, right? Write x, y, z and write x, y, z over here, right? Now, what is the first cell corresponding to? It is corresponding to x into x, that is x squared. So, what is the coefficient of x squared? It is a. Write it over here, right? Similarly, let us move to the next diagonal position. It is y into y. So, what is the coefficient of y squared? It is b. So, place it over here and come to the third diagonal position. It is z into z, so it is z squared. So the coefficient of z squared is c, so place it over here, right? So all the diagonal positions are done. Now let us come to the next cell. Which cell is this? This is x into y. Similarly, which cell is this? This is y into x. So xy is same as yx. So what is the coefficient of xy? It is 2h. So you divide it into two parts because there are two equal positions. So take their halves, place h over here, right? Similarly, let us take this position. This is x into z. Similarly, this is z into x. So xz is same as zx. So what is the coefficient of zx? It is 2g. So place half of it, that is g and g over here. And similarly, the next position, let's come to this. This is yz and this is zy. So again, yz and zy are same. So the element yz is having coefficient 2f. So what will you do? You will take its half and place y, half of f, that is f and f over here. So this is how you get the matrix of the quadratic form. So it is basically the diagonal positions are coefficient of x squared, coefficient of y squared, coefficient of z squared, and then accordingly whatever elements are taking the positions x, y, you will take half coefficient of x, y there. Whichever positions are corresponding to x, z, you will take the half coefficient of x, z there. And the last position is for y, z, you will place half coefficient of y, z there, right? So now let us try to convert this quadratic form into a matrix notation. So how to do it? Let's form the matrix first. And let us try to assume that the first place is x, the second place is y, the third place is z. Similarly, this is x, this is y, and this is z, right? Now, the first position is x square, and what is the coefficient of x square? It is 1. So, we will write 1 over here, right? Now, the next element is y square. So, y square is this place. So, the coefficient is 2. The third place is z square, so that position is here, and the coefficient is -7. So all the diagonal positions are done. Now let us switch to the next position, that is xy. So which two positions are corresponding to xy? This one and this one. So the coefficient is -4. So take half of it, write -2 over here. So place -2 over here, right? Now let us move on to the next position. This is xz. So what is the coefficient of xz? It is +8. So take half of it, write 4 over here. You will get 4. And then lastly, we have the position of yz. So the coefficient of yz is 5. So take half of it. You will write here 5 by 2. So this is the matrix for the quadratic form. So I hope it is clear how to obtain the matrix of quadratic form. Okay. So let us work out another example. So you have to obtain the matrix of the quadratic form x squared plus 2y squared minus 7z squared minus 4xy plus 5yz plus 8xz. So I think this is probably the same question. So you can just do it as a exercise again so that you get a grip at how we are converting this quadratic form into the matrix notation, right? So now let us try to do this question. You have the quadratic form as 2x squared plus 3y squared plus z squared minus 3xy plus 4yz plus 2xz. So let us assume that these positions are x, y, z. And now very comfortably you can just compute the values of x squared. So the coefficient is 2, the coefficient of y squared is 3, and the coefficient of z squared is 1. Now these two positions are referring to xy. So xy, the coefficient is minus 3. So we will write here minus 3 by 2 and minus 3 by 2. Right? Similarly, these two positions are corresponding to xz, and the coefficient of xz is 2. So we will take half of it. So we will write here 1. And then lastly, we have the positions of yz. So the yz coefficient is 4. So we will take half of it and we will get here, right? So this is how we obtain the matrix. Okay. So now we are given the matrix and we have to write the quadratic form. So just the opposite of it. How to write it? So first of all, we will target all the diagonal positions and we will assume that these places are x, y and z, right? So now x square position is 1. So we will write 1 into x square plus y squared, the coefficient is 0. So we will write 0 into y squared plus the last is z squared. So we will write it as the coefficient of z squared. Now, this position and this position, it is referring to the variable xy. So 2 plus 2 is 4. So we will write here 4x into y. Right? Now let us look at these two positions. These two positions are corresponding to yz, isn't it? So 3 plus 3 is 6 and we will place the variable yz over here, and then 5 and this 5. So this is referring to the coefficient of xz. So 5 and 5 is 10 and we will get here 10xz. Right? So whenever you are converting the quadratic form to a matrix form, whenever you have to place the coefficients of x, y, yz and zx, you will take half of it. And when from the matrix you are converting into a quadratic form, you will add up. So you will take the double of it. Right? Okay. So let us try to do another exercise. So you have this and you have to write the quadratic form of this matrix, right? So how to write it? 3. 3 refers to 3x square plus 0y square plus 3z square. Right? Now, let us take the next position. This is xy and this is xy. So 2 plus 2 is 4xy plus. Let's take the next position. This refers to xz, and which other element refers to xz? This refers to xz. So 4 plus 4 is 8xz. And similarly, we have 4yz and 4yz. So that is also becoming 8. Clear? So if you have any doubts, pause the video there and again watch it. Right? Okay. So let us move on to the next topic, that is nature of quadratic forms. Now we are comfortable that whatever is the quadratic form, we can convert it into a matrix notation. And similarly, from a matrix notation, we can convert it into a quadratic form. Now, what is its nature? Now, suppose if we have a quadratic form x transpose ax in n variables, then that quadratic form is said to be positive definite if all the eigenvalues of the coefficient matrix A are greater than 0, right? So from the name positive, it means that the eigenvalue should be greater than 0. So I hope you remember what are the eigenvalues. If you are not done with it, the concept is not clear, do check my video on eigenvalues and eigenvectors, right? Next, the next form is negative definite. Negative definite means when all the eigenvalues of the coefficient matrix A is less than 0. Then we have positive semi-definite. Positive semi-definite means when all the eigenvalues of A are greater than equal to 0. That means at least one eigenvalue should be equal to 0. At least one. Right? Similarly, we have negative semi-definite. If at least one eigenvalue is less than 0. So we have is equal to 0. That means A should be, the eigenvalues of A should be less than equal to 0. And indefinite means when some eigenvalues are positive and some are negative, right? So I'm again repeating, it is positive definite when all eigenvalues are greater than 0. Negative definite when all eigenvalues are less than 0. If one of the eigenvalue is becoming 0 and the rest are greater than 0, then it is positive semi-definite. If one eigenvalue is 0 and the rest of the eigenvalues are all less than 0, then it is negative semi-definite. If there is having a mixed nature, some are positive, some are negative, then it is called indefinite. Right? Okay. Now, let's see the nature of this quadratic form. So we have to find the nature. So before we move on to calculating the nature of the quadratic form, let us first try to find out the coefficient matrix. So we have 1 here, 5 here and 1 here along the diagonal positions. XY, the coefficient is 2, so we will take half of it. YZ, the coefficient is 2 again, so we will take half of it. And XZ is 6, so we will write here 3. Right? Now we need to calculate the I. So this is my coefficient matrix A. Now I need to calculate the eigenvalues. So we know that for eigenvalues, I have to take the determinant of A minus lambda I is equal to 0. Now to calculate the determinant, I told you that one method is you can compute this matrix and then you take its determinant, put it equal to 0, solve that equation and you will get a cubic equation in lambda, right? The shortcut method is that you can take this equation lambda cube minus trace of A into lambda square plus sum of minors along the diagonals into lambda minus the determinant of A should be equal to 0. So you can see that alternatively we are putting plus and minus. So now let us try to calculate the trace of A. What is the trace of A? Trace of A is the sum of the diagonal entries 5, 6, 7. So it is 7. What is the sum of the minors along the diagonals? Let us take the first minor along 1. For 1, the minor is 5 minus 1, that is 4. For the second place, for this as the minor is 1 minus 9, that is minus 8. And the third one, this one, it is 5 minus 1, that is again 4. So 4 plus 4, 8, so it is becoming 0. And what is now the determinant of A? So for that, let us calculate 1 times 5 minus 1 is 4, minus 1 times we have 1 minus 3, that is minus 2, plus 3 times we have 1 minus 15, that is minus 14. So we get 4 plus 2 minus 42. Right? So how much will I get? I will get minus 36. Clear? So my equation becomes, the characteristic equation becomes lambda cube minus 7 lambda square. Sum of minors is 0, so this term will become 0 and I'll get here 36. I'll get a plus 36 here because I already have a minus sign, right? This is equal to 0. Clear? Right. So now let us try to solve this equation and see what is one possible root of this equation. So please solve it and let me know what are the possible values of lambda. Will lambda equal to 1 satisfy this equation? You can see it is not getting satisfied. Let us put lambda equal to 2. So if I put lambda equal to 2, I'll get 2 cube is 8 minus 2 square is 4. 7 into 4 is 28 plus 36. Nowhere it is becoming 0. Let us try the next one. Let us try with 3. 3 threes are 27 minus 3 threes are 9, 9 sevens are 63, and we have here 36. So can this be one of the solutions? 7 and 6 is 13, 1, 3, 4, 5. Yes. So lambda equal to 3 is one of the possible roots of your equation, right? Now let us try to divide lambda equal to 3 and this given equation to get a quadratic one. So we are placing 1, then the next coefficient is minus 7. Then lambda is not there, we'll write 0 and we have 36 over here, right? So bring the first term as it is. Multiply 3 into 1 is 3. Add them, minus 4. 3 into minus 4 is minus 12. Add, minus 12. 3 into minus 12 is minus 36. Add them. You will get a 0. So the coefficients of the quadratic term is now lambda square minus 4 lambda minus 12 is equal to 0. So now let us try to solve this by middle term splitting. I'll get lambda squared minus 6 lambda plus 2 lambda minus 12 is equal to 0. So let us take out lambda common. Lambda into lambda minus 6 plus 2 into lambda minus 6 is equal to 0. So what are the possible values of lambda? One lambda is 3. The second lambda value is 6. And the third one is minus 2. Right? So how are the values coming out to be? You are getting some of the eigenvalues as positive and some eigenvalues are negative. So what is the nature? The nature is it is indefinite. Right? So you have to work out to calculate the eigenvalues, and whatever the eigenvalues are coming out to be, accordingly you can decide the nature of the quadratic. Clear? So I hope the question is clear. Okay. So now you can try this question. Find the nature of this quadratic form. So you can convert this into a matrix and then you can calculate the eigenvalues of that matrix. And depending upon the eigenvalues, you can tell the nature. Do give the answer to this question in the comment section and I will do reply to your answers, right? Okay. So thank you so much. I hope you have understood the topic. So wherever you think there is a doubt, you can always pause at that section and you can always ask your doubts in the comment section. So thank you for watching. If you like the video, do hit the like button and do subscribe my channel to get the latest updated video. Have a nice day.